So guys, our first chapter will be sets. So today we won't be going much on sets. We'll be only having an introduction. So the first question that anyone should ask when they start a new chapter or when they study a new thing, what are they? Sets. So what are sets? So sets are basically a collection of things. Now you have heard of a pencil set, you have heard of a pen set, you have heard of a stationery set. So there are different. So we have things, we take categories of things, and those things we can say are sets. Now, for example, a geometry set. Why we call it a geometry set? Because it is a set that has everything that we need for a geometry class. A football team, is it a set? Yes, because the team setting. Look at the team setting. This has a team has 11 players, and whichever order they may be, that 11 players is a set. The order might change. Here now there's 2, there's 5 here, there's 3 here. It could be 3, it could be 4, it could be 3, and it could be 1, it could be 5, it could be 4. Anything would happen. Any order can come, but the name of the players and the players will be the same. The total number of players and all the players will be the same. So the set, that is a set. Now, a library. A library is a very good example to learn sets, because when you go to a library, we don't see all the books stacked up together. We don't see physics, chemistry, biology, math, and all the books kept together. No. We see that maybe one section is kept for physics, maybe one section is for chemistry, one section is for math, and maybe one section is for literature. One might be something else. So geography. So it can keep. So in library when we go, we see that different shelves have different category of books. Each category is another set. Now when we go a bit more into math, we'll see this is a set of quadrilaterals. Wait, what is quadrilaterals? Quad means 4. Lateral means side. 4 side. Therefore, it is a 4-sided shapes. So these are all 4-sided. This is a set of 4-sided shapes. That's one set. A set of triangles. Equilateral, isosceles, scalene, right triangle. You learned all these types of triangles. Your best friends. Oh, wait, is your best friends a set? Think about it. If I tell you to write 5 of your best friends, the names of 5 of your best friends, you can give me 5 years. And if you tell me to write, I will also give you 5. Will they be the same? Nope, it cannot. Therefore, we do not consider your best friends or my best friends as a set. Why? Because it cannot be uniformly applied. Because for the same set will be different for you and for me. In mathematics, we call something a set only if it can be uniformly applied to everyone, and if it can be well defined. For you, your definition of best friends is different, and for me, my definition of best friends is different. So such type of examples cannot be taken. Now, sets. What are they now? Yes, it is a collection of things, but a well-defined collection of things. That is where sets differ from the common usage in English and in mathematics. So, if there is a well-defined collection of things, then there is no doubt If there is a well-defined collection of things, then there's uniformity. For me, it will be the same. For you, it will be the same because the definition is the same. When I talk about definition of a set, the well-defined. When I talk about a well-defined set, you'll understand it more in the later slides. I'll tell you. So when we um, write a set, we can write it in two ways, two forms: roster or tabular form, or set builder form. Now, guys, this is roster. When in your exams, then please do not write rooster because rooster is different from roster. The roster means um, a list to do. See, whenever you find such terms and definitions and all, it's better try to find out the meaning from the name of the term itself. For example, now we have a term called roster or tabular form. What does it mean? Try to think about it. Tabular form basically means a table. Roster, a list. So this looks like a table, a list. So that is the idea that should come to your mind when you read about this form. Now, roster form or tabular form. All the elements are directly mentioned in the list. Now this is also called a listing method. In here, there's nothing to think, there's nothing to derive, because directly all the elements are directly given here. This type of writing is called roster form, roster notation, or however you call it. Now, whenever we write a set, any type of set, this is how we write it. First, we write the set name, then we write equal to, and then we define the set. Set builder form. Look at the term and try to find out the meaning of it. Set builder. That means this form helps us to build the set. Yes, that is how the set works. Now, all the elements are not directly mentioned in the set. The method to find the elements will be mentioned. Yes. Look here. X is such that, okay, this symbol means such that x such that x is such that x is greater than or equal to -2. We have given a definition for a set. Look, we have given a definition. This is why I said a set is always a well-defined collection of things. You can always give it a definition. So this is the definition given to the set, that is x is such that x is greater than or equal to -2. Here I am not telling you which all are the elements, but I am telling you how to find the elements. So how do you know which are the elements now? How do I convert it into roster form? Every element is greater than or equal to -2. So the set will be -1, 0, 1, 2, 3, 4, 5 and goes on, because it just says it's greater than. We don't know where it will go. Now why is this writing used? This looks a bit weird, right? Why is this writing used? Because it is highly useful when there are too many elements in the set. Now, when there is only 5 or 6 elements, you don't have to use a set builder form. But look at this case where x is greater than or equal to -2. If you write it in roster form, it will never end. So what can we do? So we cannot keep on writing it. Well, you can, but it is now not feasible. So what we can do? So we write it in this form, and that is why it is called set builder form. From this form, we can build a set. Now, there are different symbols that we'll be using here in this chapter. Not in this chapter, but elsewhere. This is how we represent a set. We use this type of brackets. This type of brackets are called flower brackets or braces. So we use such type of brackets to represent a set. Then we have this symbol. This symbol is called element of. Looks like an E, but it's not exactly like an E. So this symbol is called element of. Whenever we use this symbol, that means we should read it as the element of. This is a universally accepted These are universally accepted mathematical symbols For example, if I write element of, this is in English. A person who doesn't know English will never be able to read this. But this is a universally accepted mathematical symbol. In whichever language, if you write this symbol, it means it's an element of. Now, let's look at what an empty set is. Again, try to know what from the name. Empty. There's nothing. There's nothing in the set. There's no elements in the set. This type of sets are represented by a Greek letter called phi. So this, when you see this letter in sets, phi refers to an empty set. Empty set means what? There are no elements in the set. Equal sets. Two sets are said to be equal. Okay, wait. You need not say two sets. I mean 3 or 4 or 5 or 6. Any number of sets are said to be equal when all these sets have the same elements. Not the same number of elements, but the same elements. It doesn't matter if even if the order is different. You remember my football team example. You can rearrange the players in any manner, but all the players will be the same. Right. This is the same case. Now look at this example. I have a set A, 1, 4, 6, 3, 7. I have a set B, 7, 6, 3, 4, 1. Does it look the same? At first sight, no. But look carefully. Every element in this set is also there in this set. See? 1, 4, 6, 3, 7. Therefore, it is equal. Therefore, these are equal sets. Now, so here, say you can name a set anything, just a variable, you can name it anything. So I have named it, this is a set of even numbers. I have named it Satish. These are the set of, what numbers are they? Natural numbers, yes. And I named it Lal. So, look at these sets. Do they even have an int? We keep the number of even numbers. Does it have an end? No. Keeps on going. It keeps on going to infinity. And because it keeps on going to infinity, we cannot reach an end. And therefore, these sets are called infinite sets. Okay? Now, there are some sets where we can define it like this. X is such that x is greater than 1 and x is less than 10. Such sets do have an end. And look at this set, 2, 4, 6, 8, 10. It has an end. It's a fixed set. Such sets are called finite sets. Now, look at this set, 3, 6, 9, 12. Now, look, and here I have written some more sets. 5. You know what 5 means? 5 is empty set. 3. I have written another set, 3. This is a set with only one element. A set with only one element. A set with two elements. 3, 6, 9, 12. 3, 6, 9, 12. Look at these sets. If you look at these sets carefully, you'll understand that these sets are actually the elements of this set. Right? The elements of this set are actually the elements, or are also the elements of this set. Therefore, such sets are called subsets. Why? Because these sets are all these sets are all the elements of all these sets are also the elements of this higher set. That is why these sets in the second row are called subsets. These are not only subsets, there are more subsets. I can write 3, 6 together. I can 6, 6, 9 together. See, these are all the subsets. 9, 12, 3, 6, 9, 9, 9, 12, 3, 9, 3, 12, 3, 6, 9, 12. See, now one thing that we need to look is, I have written phi also as a subset of main set y. And empty set is also because every set contains an empty set, right? See, if we add a 0 to any number, what do we get? It's the same number, right? 2 plus 0, 2. 3 plus 0, 3. So, likewise, every set will have an empty set because always there's an empty space. So, an empty set is a subset of every set in the world. Likewise, a full set 3692, see 3692. This is also a subset of the set Y because every element, because as per definition, a subset means a set should have every element of every element of a set should be there in another set. Then only it can be a subset. So every element of this set is also there in this. So this is also a subset. So in all the sets, the empty set and the full set, the set itself will always be a subset. Now, if you take all the subsets together, if you put every subset together into another set, see, set of all the subsets, that set is called power set. These are all definitions, and I know it might sound a bit boring, but these terms are pretty much important when we try to when you try to understand this chapter policy. As this is just an introduction, I'm obliged to introduce these terms to you. So power set is a set of all subsets. Okay. Oh wait. So what is this set? This set is called universal set. Why is it universal set? Because this is our basic set, our foundational set. From this set, all these sets come. So this is what we call a universal set. Now, there are few notations that we'll be using in this chapter. Not only in this chapter, I'm sorry, in all around math. One is what we studied earlier, element. And then, see, this symbol is called subset symbol. So if I write A subset B, that means A is a subset of B. So likewise, then this is a symbol phi. This is another way of writing phi, that is all. So phi is what? Empty set, or in other words, null set. Null also means empty. Suppose you want to write that a set is not a subset, then you will write this symbol. There's nothing, just write the subset symbol, slash it up. Element symbol, slash it up, it's not an element. Intersection and union I will teach you later in the further videos. Then few more things. You'll find this in your text. N is, so whenever you max, when you see capital N, it refers to the set of all natural numbers. Z, the set of all integers. Q, the set of all rational numbers. R, the set of all real numbers. Now look at this, set plus set of positive integers. You don't have to learn this. Just look at this. Set, if set is the set of all integers, set plus will be what? Positive integers. Q is rational numbers. Q plus is positive rational numbers. R is real numbers. R plus is positive real numbers. So if God willing, I'll be posting a video on the difference between all these types of numbers, so that this thing, because the differences between natural numbers, integers, rational numbers, real numbers, complex numbers, all these numbers should be clearly defined in your mind, because otherwise you will really get confused when you start solving the questions. So God willing, I'll also try to post a video concerning this. So this is all what I have to tell about sets. So this was just an introduction, and God willing, we'll start moving on to more. We'll we'll go more in the further videos. Before that, there will be an assignment also along with this video, which I'll be putting into the app. Do solve the assignment and see if you get doubts anywhere. And if you feel that you're not understanding anything, or if you feel that you have not understood anything, or if you have a doubt, do contact me some or the other way, and feel free to ask me. And remember that the beginning of the year is always the best time to clear up your doubts, to clear up everything and go, because by the end of the year, teachers will get heated up, students will get heated up, and whole thing is heated up, and people will start rushing, and such type of things will be there. So it happens every year. So take this time in the beginning, since this is the beginning of the year, take this time to brush up your foundations and clear up all your doubts. If there's any doubt with the terms which I mentioned, do ask that and clear it up now itself, so that you will understand this chapter, because this is the foundation in which we'll be continuing the rest of the topics. So thank you guys for listening to me. Do complete the assignment and submit it on time.